Yeah, just to kick off, thanks so much for inviting us, Mine. We're really happy to be here and chat a little bit about our experiences, um, talk a little bit about how we came into working at the FT on the visual and data team. And we're just going to do a brief sort of overview of some of the kind of ideas we think are important for data journalism, and then we'll turn it over at the end just to open it up to questions. So just to kick us off, we'll just first kind of quickly introduce ourselves so everyone knows, where we're coming from. So hi, everyone. I'm Caitlin Gilbert. I am the US data and visual journalist. It's a strange title, but I've been at the FT, the Financial Times, for almost 4 months now. And before that, I was working as a graphics journalist at Reuters Graphics. And so that team was sort of a standalone team that worked for the entire Reuters news agency around the world. So it was a very cool experience. And then prior to that, I actually spent the bulk of my time, probably about a decade or so, in academia. So I actually came from the world of neuroscience. And so I did my PhD work at Rockefeller University, and happy to talk more about that if people are interested in it. But it had a lot of data science components to it. So that's sort of the transition I made from data science to data journalism. So I'll pass it over to Christine and have her introduce herself.
Great, thanks so much. My name's Christine. I'm also on the US data and visuals team here at the Financial Times in New York. I started at the FT coming on 2 years ago in 2020 as the US elections reporter. And before that, I worked as a data journalist at the Baltimore Sun. And my previous job in journalism was on the LA Times data desk in 2016. So I've definitely seen a lot of interesting election cycles. But contrary to what that description may give you the impression of, I don't necessarily come from a journalism background either. I did a lot of economic research in Washington, D.C. Before I realized that I really wanted to learn more about data journalism, and really was inspired to explore and consider the field. And actually, in the next couple weeks, in early February, I'll be starting a new job on the graphics desk at the New York Times. So just really happy to be here and continue exploring this topic. And Sam Lerner is also on the call. Sam recently joined the Financial Times last week, I believe. So he's here as well, and will be around to ask questions. Feel free to leave questions in the chat as we're presenting. Sam, are you here?
Yeah.
Oh, great.
Sorry, can you hear me?
Yep.
Okay, great. Yeah, as Christine said, I actually just joined FT last week. I'm on what's called the visual storytelling team and work as a graphics journalist. And before that, I was on something called the interactive news team at the New York Times. So Christine and I are doing a bit of a trade. And yeah, prior to that, I actually also came to journalism a little later. I was a computer science student in college, and I worked at a coding boot camp for several years in a technical and data role. So I've done some of this stuff in a lot of different contexts. I've done some freelance work as well for some sites like The Pudding, and I've put together a good amount of open source projects on my own, mostly using public or civic data. So yeah, I'll mostly be here just to answer questions at the end, but really excited to talk with you all.
Okay, so many or even most of you may have already heard of data journalism or visual journalism, especially after 2020 with between like the pandemic and the election. I kind of feel like graphical presentations of data analyses have been brought more into the mainstream. But it still can be pretty confusing to understand what it actually is that we all do from a day-to-day basis. So if you go to the next slide, you'll see a lot of different job titles for essentially what data and visuals reporters do. If you'll notice during our introductions, Caitlin, Sam, and I all have different job titles technically. So my job title is data reporter. Caitlin's job title is data visualization journalist. And Sam's job title is graphics reporter on the visual storytelling team. So there's a lot of different names for what we do and a lot of different classifications. It was really hard for us to come up with broad categories to describe our work to you, but we've done our best into putting our work into three big groupings that we think are pretty representative. So the first grouping is collecting and making data accessible. The second is stories that analyze data and primarily showcase data analysis. And the third are projects that visually present data to the public. Obviously, there are overlaps across these categories, and it's by no means exhaustive, but we think that providing some examples will give you a better idea.
So for this first category, I think, yeah, collecting and making data accessible to the public, it's probably the most visible example of this in the past few years, as Christine alluded to, is of course been COVID-19 data. There's just a ton of data available for every metric imaginable, many different data types, different qualities of data. And so part of our job as data and visual journalists is to actually collect and process data in a way that's accessible and clear to a public audience. And so just as an example of what we've been doing at the Financial Times for this, so these screenshots are just from our live, so regularly updated vaccine tracker. And so this is a global vaccine tracker that the FT manages along with a couple other different types of trackers, but just to showcase the kind of work we do to take in data from all around the world and present it in a way that's clear, can tell and show clear trends in data, if there are stories to tell there, and importantly also create tools that allow people to look at the data that they want to look at. So just as an example on top here, we have this breakdown just to show countries broken down by income level and then looking at the progress of their respective vaccination campaigns. Shown a different way, you can actually look at the breakdown of those countries sorted by GDP on the bottom left. And you can look at that change actually over time. So this is as of yesterday, pretty much, but presented in such a way that you can actually look at that change over time. And the bottom right is just a few countries, number of vaccination doses administered. And the cool thing we have here is you can actually change how the data is presented. So we're not actually telling someone like this is the only way you can look at data. We're not choosing the countries you have to look at. There's a drop-down list. You can select the countries you want to look at depending on your questions or interests if you live in a certain country or you want to compare a group of countries. And so this is important just because no one person should have to, collect this all themselves, as our sourcing list indicates. So really importantly, all of the data we're presenting to the public comes with, at the bottom of every page, this long list of data sources and data notes to actually point to where we're getting the data from. Oftentimes, definitions and data releases and reporting, these can all vary depending on where the data is coming from. So we want to be as transparent as possible when it comes to sharing this information. And also lets people reference our work and understand if they wanted to also look into similar questions or do their own analyses. They know exactly where to go. It builds trust with their audience. So this is a really key part of making data public.
So some of the most powerful stories come from after the data has been collected and gathered, analyzing that information and showcasing the new insights from the data analysis in stories, for example. One really powerful instance of this is by the nonprofit journalism outlet called The Markup. If you haven't heard of The Markup yet, we really recommend that you check it out. They specialize in tech reporting. They hold tech companies and algorithms especially to account. So this story from last year analyzed federal mortgage data to show that people of color, especially Black people in the United States, have been denied mortgages at higher rates than their white counterparts. That disparity between the two races exists even after controlling for other factors, such as credit scores, as you can see on this line chart. So on average, just looking at Black and white, if there are two people, one Black and one white, assuming they have the same credit score and they earn about the same income, imagine that both apply for mortgages. According to the Markup's data analysis, on average, the Black applicant will have a higher denial rate for that mortgage than the white applicant, regardless of credit score or income. So that is obviously a really powerful and stunning finding, and really speaks to a lot of the disparities that we've seen historically and still today. The Markup is also really great, not only because they published that story, but also because they shared the methodology behind how they calculated the numbers in a section called Show Your Work. And they even post on GitHub the underlying data and the code that they used to run the regression models that allowed them to come up with those findings. So that if you wanted to, you could replicate some of their statistical analysis exactly, or if you disagree with their statistical models, you could customize it to your own liking. So as Caitlin mentioned, this is the kind of transparency that's really important for building trust with audiences, and also for creating a level of rigor in the data analysis work that is rarely seen.
I also love this example in terms of collecting data. I'm not going to show it here because it's quite a long video, but I totally recommend. This is a free to watch video that the Wall Street Journal put out, a video investigation last year. So as some of you might be familiar with, social media algorithms can be quite hidden and black boxy. TikTok's probably the most so in terms of how the app works to serve content. And so the Wall Street Journal essentially set out, because they couldn't access the data, there was no public data available about what the algorithm was actually doing. They kind of created their own natural experiment to collect the data themselves and build a database to understand how TikTok's algorithm was working. And so what they actually found, more so than pretty much anyone else studying the platform, was that the app was measuring. And I can drop a link directly for this too. We'll also share in the slides as well, the link for the video. But they essentially found that the only real marker that determines what video you're served next is how long you spend on any given video. So if you spend a certain amount of time on the video, you watch a video through versus watching maybe like a couple seconds of it, that tells the app, okay, I'm going to serve you more content, either more like this or not like this. And just an example from this video of sort of how they're mapping out the types of content. So they usually start off by serving users mainstream content that's sort of at the center of that web in the GIF. And you can go into these really, really, if you've ever experienced the app, spending time on TikTok, you kind of know what I'm talking about here, where as you spend more and more time, you get served more and more niche content, and you branch out into more niche types of content. And so, yeah, Wall Street Journal did this by essentially creating hundreds and hundreds of bots that they set to have specific preferences and identities. and then let them loose on the platform to then collect this information. So to me, this is like a fabulous example of the kinds of work you can actually do when data isn't accessible or available to a journalist. And then the third sort of category we set out to chat about is this visually presenting category. So, you can do a ton of data work and build beautiful stories just around data analysis and collection. But a lot of the work also involves sort of visually presenting data in a way that is arguably more compelling than simply just writing out the text or writing out the code or what have you. So just a couple examples here. I'm actually going to jump to the page. So let me just reshare here. Okay, give me one sec. Yeah, so this is a great example from my former colleagues at Reuters. So a lot can be said, this topic around deforestation. A lot can be said in terms of, big numbers, like this is how many acres have been cleared out. This is the rate at which this is happening. And those numbers can be impressive, but they don't mean much unless you provide a context to them. And so a really beautiful graphic piece like this page, I'm just gonna start scrolling through so you have a sense of what I'm talking about, can actually provide the context to those numbers. And so the piece sort of follows this classic scrolly format, where as you scroll down the page, you're presented with more content. And the cool thing here is that actually as you scroll, there's a time element. So you get a sense of the rate in real time as you're experiencing the page. So you're visualizing the deforestation happening as you're going through the page, which adds some more scale elements as well too. And then in addition, the number 683 doesn't mean too much unless you compare it to an actual reference size. So in this case, it's Greater London, the entire country of Belgium. So just providing context for numbers, but visually laid out in a way that's very, very compelling. So you're able to tell a story that would otherwise be fine. You can write it out as text, but it becomes immediately much more compelling when you provide these visual elements to the story. So yeah, just scrolling through to show some more examples here, but totally recommend reading the whole piece because there's like a ton of data and interest in this piece. Okay, I'm gonna bounce back over here. Go back to slideshow. Okay.
So I saw that somebody had posted 538 into the chat before. And so I would just like to say that I think that 538 and election reporting has done a lot to popularize the concept of data journalism. And certainly, as the elections data reporter in 2020, I spent a lot of time thinking about election maps, which can be some of the most compelling visualizations of data. Some of you may have even seen this extremely detailed map of the 2016 presidential election from the New York Times. By visualizing election results by precinct, which is the smallest level of analysis, basically neighborhoods, the map allows this audience to discover things like voter islands. So on the next slide is an example of a voter island. So this is an enclave of blue or red that stands in contrast to its neighbors. And they have even updated the map for 2020, which is the next slide. And the 2020 map is missing a few states because at least the time that I checked it, those states were still missing precinct level data, which is kind of a sad state of affairs if you think of how not transparent that kind of data is. But anyway, election maps are notoriously tricky to get right. not only because it's hard to get all of the data in the first place, and you might end up with some missing pieces as shown here, but also because it's a challenge how to responsibly represent that data. So one thing that may be potentially misleading about that New York Times map is laid out in this Twitter thread by John Schleifs, who is a former LA Times graphics reporter. John took issue with the fact that the New York Times map does not adjust for population density. So you have this sea of red in the center of the United States. Yes, it's true that the so-called heartland of the US definitely overwhelmingly votes Republican and voted for Trump. But those places are also less populated. So there are fewer people in those places. So this is an example that John posted about showing the suburbs around Bakersfield, California. So on the right-hand side, you have the LA Times version of the map. As a local news organization, they pulled together precinct level data just for their region. And so on their version of the map, the suburbs are shaded with less opacity than the city itself because there are fewer people in those areas. Whereas in the New York Times version, they do not adjust for the population size. So to take a more concrete example even, say that a precinct contains just 5 voters, 4 of them who voted for Trump. So that would be an 80% vote share for Trump. But does that mean that the precinct should be shaded in the darkest shade of red because it's 80%? John would say no, because only 5 people live there and only 4 of them, are actual voters. But the New York Times map would in fact show that in the darkest shade of red. But to be fair, on the next slide, I put a response to John's critique by Josh Katz, who is one of the graphics editors at the New York Times and one of the creators of this map. He says, if you want to count who won the most votes, using opacity makes sense. But if you're interested in the political character of a place, reducing the visual weight of low population places, literally making them harder to see, suggests those places aren't worth caring about. So the point is not to say who's wrong or right. I think those are both valid insights. The point is that being a data journalist and a graphics journalist also means making these decisions, where sometimes the right answer really just depends on the context, and sometimes there really is no right answer. It just depends on what you want to show. So another instance in which this is the case, oh wait, no, never mind.
Yeah, just to add, continuing on the election theme. So this is what Christine and others worked on for the Financial Times for the last election, and a lot of thought is put into place in how we actually showcase this. So obviously, the New York Times precinct level has its own issues, regardless. But even at the state level, right, there's a lot of consideration that goes into actually how we represent results. So in this case, it's just electoral college votes by state. And so combining both the actual map of the United States while also representing that some states obviously have a greater share of electoral college votes. So showing both actually at the same time is not a trivial matter. And one of the most important considerations actually when it comes to an area of visualization around accessibility concerns, which there are a whole host of things that could be its own talk. So I don't want to devalue that, but just to say, one of those considerations that we really take seriously at the Financial Times is accessibility for those who might have lower limited vision or color blindness. And so we actually do go out of our way to sort of simulate different types of color blindness. There's not just one type, there are many types, and actually look through our visualizations to make sure we're choosing palettes where you can still discriminate colors, you can still see differences and all that. So that really does go into really every level of how we're designing visualizations at the FT, as I'm sure other places do as well. So yeah, just to add that accessibility note.
Okay, sorry, I skipped ahead a little bit, but the example that I was going to mention on the same point of not, there not necessarily being a right or wrong answer, a right or wrong way, is the example of log versus linear scales. So over the past couple of years, that has become a really hot button issue when displaying things like COVID cases, whether to display them on a linear scale or whether to display them on a log scale. So this was a question posed by our London colleague, John Byrne Murdoch, who was making some scatter plots of the prevalence and growth of COVID cases by local authority in England and Wales. So if you look on the right-hand side of this slide, the top, this is exact same data that he's showing. The only difference, so on the x-axis is the new cases per 100,000 people, and the y-axis is the week-on-week change in cases. So the only difference is that on the top chart, it's a linear scale and everything is presented as shown, whereas on the bottom chart, the x-axis is adjusted. It's a logarithmic transformation of the data. So it's on a log scale, and you can even see that with the tick marks. They're not evenly spaced for that reason. So when I first saw these two charts as a data person who's worked a lot with data that is skewed in one direction or the other, I was inclined to say that using a log scale would be better, aka the bottom chart, because that way you can see the different points much easier, and you can kind of understand and not feel so squished when you're looking at the data. Just aesthetically, you're making use of more of the space. And you're also making use of the fact that things like COVID cases do not follow a linear scale when they're increasing. They increase exponentially over time. So it can just as easily double from 20 to 40 as it can from 5 to 10. However, I thought about it some more and I asked John what he thought, and he said that the top chart may also be better, though, if you're trying to make the point that there are some outlier areas in England and Wales, like those three on the very right, where they have very alarming infection rates. And then there are lots of places currently or at the time where infections were very low. So that point is perhaps better highlighted in a linear scale where the outliers really pop out. Versus everything being spread out more evenly. So again, I encourage you to think about this a little bit more. In the slides, which we will send after the presentation, we link to some of these different posts, and there's just some really interesting discussions around log scales versus linear scales and a bunch of different topics as well.
Okay, and just to wrap up, so we presented this sort of loose framework for the different types of work folks in our field might be doing on any given basis. And so that also means that there are a whole variety of skill sets, tools, programming, coding languages we use on a regular basis. I don't think there's any one person that has mastered every single element of this whole pipeline of skill set. There probably is, at least maybe somewhere, but not to my knowledge. So we just wanted to kind of collect a few of the resources. Again, this is not meant to be exhaustive, but just give a sense of the types of tools and technologies that we have experienced and know folks to be using. So on the front end, first we were chatting about collecting and making data accessible. And so I think there's a common initial feeling. I know I had this when I first got into the field of wanting to dive immediately into learning a new language or doing all that work. But friendly command line tools are able to do a lot of data journalism work, especially on the level of actually collecting data that might be in strange formats. If you wanted to manipulate a ton of video files, there are really cool tools to do that. If you wanted to manipulate like a terabyte of CSVs or something, you could do that in command line very readily. So yeah, I really do recommend command line tools for for a lot of kind of the data munging and collecting. Um, Kind of a newer, I guess, technique that has evolved over the last few years. I linked here to Simon Willison's guide to what he called Git scraping, where he essentially uses GitHub Actions, which some of you might be familiar with, to essentially automate scripts and pipelines. So you could, for example, pull in data from a government website every 15 minutes and just like have that run so you don't have to manually do that on a regular basis, which makes data journalism life a lot happier. And then there's like a whole bunch of web scraping type tools you can also play around with. It's pretty language agnostic. You can do it in many different languages depending on your preferences. But when I say web scraping, I just mean, let's say data is not readily downloadable or accessible from a website and you wanted to pull information from a website, whatever that might be. If it's election results from a PDF that's being hosted online, that's an example I've encountered. If it's mining a social media site, like these are all kind of loose sort of scraping type tasks. And then when it comes to actually analyzing data, so I guess what we call more of like the back end side of analysis, there are many, many languages to do this work in. So I predominantly use R, but I think there are many different languages that can do the same work, especially Python. So we just listed a few sort of resources here. SQL is also great for database work. And so if you're interested in getting into that, we've also linked a couple of guides here. And then spreadsheets kind of power a lot of data journalism work, especially when you're collaborating with folks who might not be as familiar with coding. Google Sheets, Excel, like whatever your favorite spreadsheet program is, they're very good to be comfortable with, I think, if you're going into this field. And then probably the place where there is the most number of tools when it comes to the task at hand, and it's kind of readily changing also in real time. When it comes to actually building graphics, either digitally or even for print, we have a whole suite of tools that we use. So just a few, I think some of the more common ones we use. So the Adobe Creative Suite is like my bread and butter. I use it almost every day when I'm building graphics. So Illustrator is my best friend when I'm refining graphics for, especially for print as well. If you're building something on a web page or something that's interactive, we use a lot of JavaScript or some combination of HTML, CSS. Svelte's probably a newer framework, but all to the same end of building web-based and also potentially interactive graphics. So similar to what I was showing you for the Reuters deforestation piece. And then there are like a whole bunch of other kind of tools that kind of let you build visualizations within frameworks. So things like Data Wrapper and Flourish. At the FT, we use Flourish quite a lot. Mapping tools, so Mapbox, OpenStreetMap are just a couple, but there are others as well. And then observable notebooks as well to actually, I mean, I didn't get into reproducible code, but yeah, you can actually do some really cool stuff there as well. So just, again, not an exhaustive list, but just to give you a sense of sort of how we categorize the types of tools we use for different tasks. And obviously happy to answer more questions about this too.
Great. So some of the tools that Caitlin mentioned, especially the data analysis tools, the guides to those tools were written by journalists. So I find them very much easier to understand than some other more technical guides. Some other tools that journalists like to use are things like Census Mapper and Census Reporter, which was also created by a group of journalists as well. Census Reporter is really useful for understanding the demographics of an area according to the US Census data. So if you're ever curious about a given neighborhood or city or state, I would really encourage you to explore Census Reporter. It has a really user-friendly interface, and you can see things like the age distribution or race and ethnicity distribution of a place just at a click of your mouse. And some other things that I wanted to point out were things about the where to find data sets. Some of us subscribe to a lot of email newsletters, including the Data is Plural email newsletter, and there'll be a link in the presentation. It's a weekly newsletter created by the data editor at BuzzFeed, where he points out really interesting and free freely accessible data sets that he's come across over the past week. The investigate.ai is another one to point out. It was started by a journalism professor, I believe, who sought out to replicate the data analysis and research that was done in certain news stories. So if you go to investigate.ai/projects, you'll see that he's done the work of pulling together the underlying data that powers some really interesting news stories. So you can explore, and I find it to be a very good teaching tool and a learning tool, because you can see how other news organizations come up with their analyses. So I think, yeah, okay. So speaking of news organizations, the Financial Times is one, and that is the place that all three of us currently work. You may be wondering how you can read the data and visual stories at the Financial Times, and even other stories too. There is a resource that the enterprise team put together called License Finder. So the Financial Times has partnerships with a lot of different schools. So we would encourage you to take a look. Oh, it looks like you may already have access. So that's great. But if you didn't, you could also take a look at this website to see to check if you did. So yeah, would look forward to hearing what you think of our stories. And just wanted to say from all three of us, thank you so much for listening to us. As you can see, we are all very nerdy in different ways, and we are happy to answer your questions. We should have a little bit under half an hour, right, for questions.